We cannot see it, feel it, or interact with it, but we know that it's there. Scientists have long known about the presence of a mysterious substance that makes up 27% of our universe, called dark matter. But how do we know that it exists? Well, while it may be invisible, dark matter affects the universe in strange ways, and that's something that we can see. Dark matter is often conceptualized as a giant spiderweb, meshing galaxies together as it exerts its own gravitational force. And because this substance is in such high abundance, it has enough force to hold together entire galaxies. This effect is evident when looking up into the night sky. If you observed a faraway galaxy with a telescope, it would appear stretched out and oddly shaped. We see it that way because of gravitational lensing, caused by dark matter's strong gravitational force, distorting the light appearance as it travels around the galaxies towards us. Though scientists have known about the presence of dark matter for some time, there is still so much unknown about this strange substance. One of the most commonly accepted theories is that it is some type of exotic particle, yet undiscovered and unmeasurable. For all we know, the gravitational theory forming the basis of many of the physics that we use to explain the universe could actually be flawed, and we attribute the effects of an undiscovered type of gravity that we don't yet understand to dark matter. Well, researchers at the University of Sussex have taken another step forward in uncovering the dark matter mystery. The team have published incredible findings outlining the mass range of dark matter. They were able to calculate this by applying what we know about quantum gravity to the forces which act on dark matter. Quantum gravity, much akin to dark matter, has been discussed in physics for some time, but very little is understood, known, or proven. To understand quantum gravity is to understand the missing piece of the four fundamental forces in our universe. The strong and weak nuclear forces, as well as the electromagnetic force, all have a quantum component which has been observed. These quantum components explain where the forces actually come from in our time-space. For example, if you put a magnet on your fridge, the force appears smooth, but when looking at it very closely, we see a bumpy magnetic field where electromagnetic waves are zapped in and out of space-time at random. This is a quantum effect. We witness a similar phenomenon on the strong and weak nuclear forces, yet we have not been able to accurately observe this effect for the gravitational force. But the long-standing theory is that it must exist, as it explains where gravity actually comes from, and without it, the universe would rip apart completely. What the researchers did was look at the quantum gravity forces acting upon dark matter and applied some extensively long mathematical equations to work out the range of mass in which dark matter must be. They calculated this to be within 10 milli-electron volts to 100 mega-electron volts for a single dark matter particle. Should the mass of dark matter be outside this range, then it would prove that there is an additional unknown force present which interacts with dark matter. What these scientists have done by quantifying this range is demonstrate that dark matter cannot be either ultra-light or super heavy, as many scientists have theorized. Additionally, this piece of research helps physicists in two ways. Firstly, it focuses the search area for dark matter, and secondly, it will potentially reveal whether or not there is a mysterious unknown force in the universe if the mass of dark matter is outside their defined range. As the saying goes in scientific research, when you find one answer, you find 1,000 new questions. And this may be the case when the true mass and nature of dark matter is finally uncovered. And that's it for this week's Temp Tech Bite. If you enjoyed the video, please remember to like and subscribe. And we will see you in the next one.